Let me write it L. Okay, we have a wedge here. It's a right angle triangle. Read the question. It's a right angle one. So definitely this beta. So what is alpha plus beta? Should be 90 degrees. Two blocks of mass M1 and M2 are connected by massless. I'm bringing tension into the picture. Till now we took only friction, now the tension. If you want, you can make the surface between the blocks and the wedge rough also. Smooth or rough, inclined plane, it doesn't matter here. The horizontal displacement of the wedge would be when M1 slides down by length L along the wedge. M1, how much it will move? A distance L along the wedge. So what is the state of wedge? Wedge will also be moving. So if you want, you can draw the diagram or take help of formula. So what formula says? M1 delta x1 m delta x equals 0. What is delta x? And I'll write 3. This is, we'll do one thing. We'll make it 3. It'll be easy for us. Now, how to confirm net force acting on system 0 or non-zero? That is what first needed, no? So if you take the net force acting on system, you have to go for the free body diagram. M2, this is M3, alpha, beta. Beta is what? 90 minus alpha. What are the forces? M2G sine theta. M1G, sorry, M1G sine alpha, M2G sine beta. Normal contact N2, N1, M1G cos alpha, M2G cos beta, M3G weight. Here normal contact N3, the tension in the pulleys, tension in the string. Even friction is there, you can bring. Even if you make inclined plane rough also, doesn't matter. Any one or both. What is the net force acting on system? You look at the block N2 sine theta, then again that N2, what happened? We have to show it on the wedge also, no? So here that N2, I'm showing it here. And this N1, no, N2 sine theta, sorry, N2, so it should be like this, N2 sine beta, here N2 sine beta, N1 sine alpha, N1 sine alpha, T cos beta, T cos beta. So again, T cos alpha, T cos alpha. The net force acting on system along x-axis 0. So I do, in fact, what I wrote this equation is justified. The blocks will undergo displacement along x-axis. The wedge will undergo displacement along x-axis, but the center of mass of system will be at rest because the system is released from rest. Net external force 0. Aggression of center of mass 0. Initially center of mass at rest. So center of mass will retain the inertia of rest position. So center of mass will not shift. So therefore, now I can write this equation. But what is information given? Only the block will move a distance L along the incline. How to bring that one? Because earlier it was a horizontal surface, no? Now there's the inclined one. Again, displacement of block with respect to wedge along the incline is L, no? And the displacement of wedge is so along x-axis with respect to wedge, L cos alpha. So here, I'll begin like this. Delta x13 equal to x1 minus x3. What is x13? Displacement of block with respect to wedge along x-axis, L cos alpha. Anything towards left, negative, towards right positive, or towards left you take positive, towards right it will be negative. It's your convenient. So I'll change direction. Why there's no rule that towards right only you should take positive. Let me take towards left positive. Shall we put sign L cos alpha? L, it will move distance along the incline L. Resolve that L cos alpha. Then we don't know this x1. We don't know this called delta x1. Then displacement of wedge. Yes, it will shift towards right, we'll assume. Negative. So therefore, what is delta x3? L cos alpha delta x1 equal to delta x3. Similarly, come for the second block, x23 equal to x2 minus x3. So how much it will move? L cos beta. It will slide up. If this moves a distance L with respect to wedge, this will move down a distance L with respect to wedge. It will move up no distance L. So L cos beta. And what is the direction? Towards left, this is a positive equal to delta x2, we don't know, minus the wedge will undergo displacement towards left. Symbols little bit trouble you, just be careful. So again delta L cos beta minus delta x2 is equal to delta x3. Let's substitute all. Just only one formula, nothing else there. You should know how to use that formula. That is what all these concepts are. Let's go back to substitution. M1 delta x1. We wanted delta x1, no? There's a thing. Delta x1 will be L cos alpha minus delta x3 plus M2 L cos beta minus delta x2. And here also you should substitute sign because delta x3 is what? You assumed it towards left, no? This will really trouble you. So how to take care of this? What I suggest you like, that's why don't put sign here. If here you are not putting sign. That's why what is the best method, like a sir, like a, you wrote equation. Now from where this minus sign has come, I had to substitute the displacements here. I have to substitute the displacement, no? I have to substitute with sign. So therefore it's advisable to not to substitute this particular sign. Are you getting no? Because here delta x3, m3 delta x3, suddenly I'm putting sign. So this will trouble you. So how to overcome this? You don't put sign here. The mistakes what usually students will do. Some books what happen, they somehow manipulated this, that. Sometimes they put sign, sometimes they don't put sign. So it's a golden rule that. So what you do, don't, delta x3 is unknown, no? So don't go for sign. Is it clear? This what I feel. This will most easiest way of learning problem. So then this will become, I'm just changing it. So this will be this one. Now similarly come for this. So don't put sign. So this will become positive. This will be negative. So you can see now you are in a far better position. No? The unknown things don't put sign, leave it. Now substitute all this. So this will be M1L cos alpha, M2L cos beta minus of M1 plus M2 plus M3 delta x. You got negative sign. What you'll interpret? What you should interpret? It will shift towards left or towards right. Got this one. So this is very important because the course of the problem just revolves around this idea. Here, if you go wrong, I think nobody can help you. That's why I'm just telling like what mistakes usually students will do. I'm just highlighting. The unknown things don't make a guess of sign. And the sign you interpret it. If we got negative, the displacement of wedge. So therefore it will shift towards right. There's the displacement of if there's a inclined plane rough, then also friction will come into picture. Then also net force along zero. I think the answer will be same. To trouble you, the inclined planes they'll make rough. One inclined plane rough, other smooth. No, nothing will happen. Whether so, if you want, you can bring it here. Mu2, this is mu1. So this answer is applicable whether mu1 0 or mu1 non-zero, mu2 0 or mu2 non-zero. Of course, the free body diagram, if you bring friction, you have to bring, if you make the inclined plane rough, you have to bring friction also. But the net force along x-axis, still it will be 0. Next, again, I'm bringing another thing. Read the question now.